I've recently been thinking about fragmentalism and how that relates to Einstein's theory of special relativity. Are you familiar with the concept of fragmentalism? Out of curiosity, I'm not. There's a philosophical view, often in metaphysics and philosophy of time, proposing that reality isn't a single unified whole, but is composed of distinct, internally coherent fragments of facts that are incompatible with each other across fragments like different moments in time or different perspectives, without a single overarching viewpoint. Well, I guess our view is kind of a fragmentalism. Like I kind of point out that the way that we can think about the semantic facts that we understand is that they would be changing from moment to moment as as these facts are manifesting because of the brain connections that are constantly being strengthened and diminished. So like the shape of the structure of our brain is constantly changing, and that leads me to believe that the way that we think about things, even facts, would differ over time. It would change. Everything is anything that you think about is being changed by the process of you thinking about it. So there's nowhere you can run in some sense where you're not dealing with a thought that isn't changing connections. So you can think about it that way. I mean, this is a metaphysical way we can conceptualize information that we know over time. But the thing that the thing I want to point out is that it wouldn't be appropriate to take this view and to then blow it up to multiple people. Like each of us have a different understanding that is constantly changing over time. So the semantic facts that we each understand or we think are true are changing over time, but they're different from each of us has a different understanding. So the fragmentalism view, in my mind, is something that you can only use for a single person. It wouldn't make sense to use it across people. Now, that being said, with I don't know how we would, the way that I just said that, I don't know how we would connect it to Einstein's theory of special relativity, because these are just different physical systems that we're talking about at that point. I'm talking about the brain physical system, and the brain doesn't really care about special relativity. But the fragmentalism, as it's described here, is ambiguous enough that you could think about it in many different ways. The way I just described is just the most intuitive that I can think of that makes sense of what we know about the brain and how that affects our experience and understanding. All right. That paper, to my understanding, discusses the relationship between special relativity, quantum physics, and fragmentalism. Right. I guess the idea of fragmentism that would be covered here, I would imagine, is a much more metaphysical, a broadly metaphysical theory about some objective truth in the universe, which I usually try to assault. But let's see what's going on here, or I try to push back on. I should say I should be less violent with my rhetoric about that. This paper examines how Presentist Fragmentalism. So what is present? Is a metaphysical and physical theory suggesting reality isn't a single continuous timeline, but a collection of discrete interconnected fragments, each with its own real unfolding now. Whoa. So this is really tricky, because what do we mean by a timeline or reality when we're talking about fragments? This makes sense if you're saying that there's multiple people out there and each person is experiencing time in a different way. But this is going to connect it to the universe's time. So this is actually kind of looking at some sort of, panpsychism, if I'm understanding this correctly. Provides a unified framework for resolving key paradoxes in quantum mechanics and relativity. PF posits that reality consists of fragments with independent A-series temporal flows, dynamic future, past, present, connected by B-series relations. So unless this is actually a straight up scientific theory about quantum physics and time, basically pointing out, let's just say, we're talking about a many worlds situation in which each of these worlds has a different sense of time. Okay, how does this type of fragmentalism contrast or perhaps resonate with the many worlds hypothesis? So that type of question is actually going to make it much easier for me to understand Presentist Fragmentalism, I think. We demonstrate PF's explanatory power through analysis of 8 fundamental thought experiments, including Einstein's train, Schrödinger's cat, EPR, and the delayed choice quantum eraser. The framework naturally resolves apparent contradictions between quantum non-locality and relativistic causality by distinguishing between B-series relations which respect relativistic constraints and A-series synchronization which enables quantum correlations. This reconciliation requires no additional mathematical machinery beyond standard quantum mechanics while providing clear ontological understanding of quantum phenomena. We compare presentist fragmentalism with other major interpretations, including Aharonov's two-time Ravelli's relational interpretation and quantum reference frames, showing how PF offers unique insights into temporal structure. The framework's success in systematically resolving diverse paradoxes while preserving both relativistic and quantum principles suggests it captures fundamental features of physical reality. Based on the provided text, the author does not explicitly discuss the many worlds interpretation. The text focuses... Yeah, I understand. However, based on the specific definitions of presentist fragmentalism provided in the document, we can infer distinct contrasts and resonances with the standard many worlds hypothesis. All right, contrasts. The nature of outcomes in time. The most significant difference lies in how each theory handles measurement, outcomes, and the structure of time. So in PF, the text describes measurement as a process that produces determinate properties within a shared present moment. When fragments merge, they establish a single shared reality relative to one another. The evolution of one fragment relative to one another is described as stochastic, probabilistic, because there is no fact of the matter prior to the merger. Aha. In contrast, in many worlds, all possible outcomes of a quantum measurement are realized in separate non-communicating branches of the universal wave function. There is typically no stochastic selection of a single outcome. All outcomes exist deterministically in the multiverse. Okay. I'm not going to be able to understand the differences here, but synchronization versus branching. PF measurement is defined as temporal synchronization where disparate A-series flows merge into one. This is a unification process. And in many worlds, measurement is typically viewed as a branching or decoherence process where a single history splits into many. Okay. Dynamic versus static time. PF, this theory relies heavily on the A-series of time, a dynamic flow from future through present to past. It posits that future possibilities actualize into present experiences. Okay, and many worlds is generally associated with a block universe, B-series only, or eternalism, where all times are equally real and there is no objective dynamic flow or privilege now. Oh my gosh, PF is working with Tenet rules on the A-series of time. Okay, resonances, realism, and no collapse. Despite their differences, PF shares some philosophical DNA with many worlds regarding how they treat the wave function and the observer. Rejection of the standard collapse. The text states the theory requires no additional mathematical machinery beyond standard quantum mechanics. It resolves the collapse problem not by a physical collapse of the wave function, but by the synchronization of time, A-series, between previous unsynchronized fragments. Similarly, many worlds claims to use only standard quantum mechanics without adding a collapse postulate. Both theories attempt to explain the appearance of collapse without a traditional collapse mechanism. And then fragmented perspectives. Reality is composed of fragments where for one fragment there is no fact of the matter about the A-series values of another fragment. A system exists in a superposition relative to an observer because they do not yet share a now. And many worlds. This resonates with the many worlds view that the state of a system is relative to the observer's branch. In both views, there is no single absolute view from nowhere that captures the classical state of the entire universe at once. Reality is perspectival. Okay. What would each theory suggest about each person's conscious experience, and do either of the theories hold not an axiom, make a conclusion, hopefully evidenced or logical, that contradicts the other? Because this type of idea is much more salient to me than the collapse, the wave function collapse. So I'm actually if that's the case, then PF is now my tied for my favorite quantum theory if it holds up. So yeah, I would definitely be stoked about that. Based on the provided text for presentist fragmentalism, and standard scientific definitions of the many-world interpretation. The two theories offer radically different pictures of conscious experience. They fundamentally contradict one another regarding the unicity of you, whether there is one of you or many, and the mechanism of your experience, whether you are creating reality or just sliding along a pre-existing track. The nature of conscious experience, presentist fragmentalism, the actualizing consciousness. Conscious experience is defined by the A series, the dynamic flow of time. Experience is a filter of becoming. The text states that the A series flow represents the fundamental becoming of reality. Your consciousness operates at the leading edge of this flow where future possibilities actually... Okay, I take everything I just said. This disqualifies PF from my view because it's missing the points of neuroscience. What neuroscience suggests about our conscious experience is that whatever reality we think that we're experiencing does not deserve the status of ontological truth. So it's not that, when we talk about reality in terms of phenomenology, we can't say that that's some objective reality that's external from us. That is our experienced reality. It's what we feel in the moment, and it's dynamic. But yeah, if the A series flow represents this this phenomenological aspect of our conscious experience, then this is looking in the wrong direction, I think. Your consciousness operates at the leading edge of this flow where future possibilities actualize into present experiences before receding into the fixed past. Yeah, this is ridiculous. I take it back. I actually have to stop right now. I don't even want to entertain this anymore. Experience is singular but fragmented. You, Alice, my name is Alice, have your own independent now. You do not experience a superposition of outcomes. Instead, when you measure something, your timeline synchronizes with the object's timeline, and a single determinate property emerges in your shared present. You see that this is like this idea of a determinate property being some property of the universe is what I am pushing back on. I think we know enough about neural correlates to know that our conceptual thoughts, our determinate properties, are manifestations of specific processes of the brain, and thus we have a clearer view of how to make sense of a determinate property than this type of view. All right, we got to get out of here then. Sorry for going so hard on PF at the end there, but it has to be done on this channel. We got to be stern about our ontological assertions because that's what my understanding of the science forces me to do. It's not because I just want things to be true. It's because I don't think the science allows us to think that way. All right, let us call it a day. But what if presentist fragmentalism is discovered by scientists and philosophers to be effective at reconciling special relativity and quantum physics out of curiosity? I mean, that's fine. It's just that it has to compete against other other frameworks that reconcile special relativity and quantum physics, such as many worlds. And the issue is that it's operating on axioms that we know are inappropriate to operate on. So regardless of if they were to have tests that show some resonance with reconciling special relativity and quantum physics, then I would say let's not throw that out, but we need to throw out the way that they're the conclusion that they're coming to, or the axiom that they're leveraging to get to that conclusion. Like we have a semantic issue here, where despite these tests that look good, you're operating on a faulty setup. Whereas even though, I wouldn't say that Many Worlds is perfect, because Many Worlds is operating on this weird setup where you have many worlds, and we can't intuit that at all. That's an issue. But it's not as big of an issue as operating on something that we know is actually inappropriate, which would be to say that there is some reality affected by or a manifestation of some external reality that's in the same domain as scientific truths when we experience the world. Like that would be inappropriate, and that's what I'm harping at. Like we have to keep, like when we're talking about reality, we have to keep conscious reality separate from physical reality. And if we're going to have a discussion about how we connect those, it has to be, as far as our science allows us, it has to be within the brain and neural correlates. Like that's it. We can't jump the gun and start saying that because something is being experienced, therefore it has some ontological semantic authority in the physical world. That's the issue there. All right, I'm gonna call it there. Thank you though for the questions. Thank you for the paper, and thank you for getting me to see that stuff, because that's more stuff to learn, more cool stuff. Have a good rest of the day. See everyone later.